Hello guys, welcome back to a brand new video. Today we're going to be doing about area and volume, leaving cert higher level max, really important topic. So yeah, before I start the video, make sure you check our channel for more videos like these, and I'll be uploading more videos soon. So yeah, make sure you like and subscribe as well, please. Thanks. So what is area? Area is the measure of the surface of two-dimensional shape, measured in square units, example centimeters squared and meters squared. Make sure it's really important to add the square units. Make sure not to forget to add the square units at the end of each questions. Really common mistake. But common area formulas. These formulas will be already given to you in the log tables. So rectangle area equals length by width, triangle area equals half times base by height, and circle area equals pi times radius squared, and trapezium area equals half times a plus b multiplied by height. These formulas will be given to you on the day of the exams and will be given to you on the log table, so there's no need to be worrying about learning these off. And what is volume? Volume is the amount of space occupied by a 3D object, measured in cubic units, example centimeter cubed and meter cubed. Make sure this is important. Don't forget to forget the units as well. This common volume formulas. Volume equals side cubed, and cube equals side cubed. Cuboid equals volume. The volume of cuboid is length times width times height, and the volume of cylinder is pi times r squared times h. Volume of cone is 1/3 multiplied by pi times r squared times h. Sphere, the volume is 4/3 times pi times r cubed. We're going to be doing some past exam questions in this video as well. So, square area of 3D shapes. Cubed is 6 times side squared. Cuboid is 2 length width plus length height plus width height. Sphere is 4 times pi times r squared. Cylinder is 2 pi r squared plus 2 pi r h. Units and conversion. 1 meter squared is 100 centimeters squared, and 1 meter cubed is 1 million centimeter cubed. Always convert units before applying formulas. Really important. Always convert. Exam questions. Really simple exam question is example question. Area. Find the area of circle. Radius 7 centimeters cubed. Area equals pi r squared equals pi times 7 squared equals 153.94 centimeters cubed. Really easy, simple question. Now find the volume of cylinder with radius 3 centimeters and a height of 10 centimeters. So volume of cylinder is v pi r squared times h equals pi times 3 squared times the 3 centimeters squared is already given in the question, so just apply it back into the formula, and the height is also being given in the question, so apply it in the formula. So pi times 3 squared times 10 equals 282.74 centimeters cubed. Common mistakes: forgetting to square or cube units. Really important. Mixing up formulas. Yeah. Not converting units. Yeah. Using incorrect radius or height. Tips for success: write down the formula before substituting. Always include units in your answer. Double check your calculations. Practice past exam questions. We're going to be doing exam questions right now. I'll be showing you past exam questions in this video as well. So yeah, practice questions. Another simple set of questions before we go into the hard exam questions. So yeah, find the area of triangle with base 12 centimeters cubed, 12 centimeter and height of 5 centimeter. Find the volume of cone with radius 4 centimeter and a height of 9 centimeter. Find the surface, third one, find the surface area of sphere with the radius of 6 centimeter cube, with 6 centimeters. Question 1, area of triangle, the formula is area equals half times base times height. Given, it's already given, the base is 12 centimeters in the question below, 12 centimeters here, and height of 5 centimeters already given in the question. So just sub in 12 centimeters and 5 centimeters in the formula here. Area equals half times 12 times 5 equals 30 centimeters squared, and the answer is 30 centimeters squared. And question 2, volume of a cone, the formula is volume is a third times pi times r squared times h. And again, in question 2, the radius is given and the height is given. So the volume is, the radius is 4 centimeters and the height is 9 centimeters. So pi times 4 squared times 9 basically is equal to a third times pi times 16 times 9. If you simplify this and just sub it in the calculator, you'd end up getting a third pi times 144 equals 48 pi. Or if you want to multiply it out, you probably get away with this as the answer. Or if you want to simplify it even more, multiply it by the number of pi equals 150.80 centimeters cubed. You can sub that in your calculator. Question 3, finding the surface area of a sphere. Formula surface area is for a sphere is 4 times pi times r squared. Again, in question 3, the radius is already given, so much easier. So surface area is 4 pi times 6 squared equals 4. So now we're gonna get into, I hope if you have any question with these questions, make sure you drop a comment down below and I'll answer your questions. So leaving cert questions, let's start. So a rectangular sheet of cardboard has a width of 9 centimeter. Its length is twice its width. Squares of side lengths is x centimeter, where x is greater than 0, where cut from each of the corners are shown in the diagram. So here is x centimeters they gave, and x centimeters, and this is 2 h centimeters, and this is h centimeters. So the sides of the sheet of cardboard are then folded up to make a rectangular box with an open top, on shown in the diagram below. So here we can just start off saying this is the height, which is x centimeters. This is the width, h minus 2x centimeters, and the length equals 2h minus 2x. See, so starting off with part A, we're told the so in part A we're given a diagram. Next we are told that the sides of the sheet of cardboard are and then folded up to make a rectangular box with an open top, as shown in the diagram. Now a box is to be made from a sheet of cardboard with h is equal to 25 centimeters. We are then told to show that the volume the box in cubic centimeter is given by v box is equal to 2 by 25 minus 2 multiplied by 25 minus x in the brackets down here. The volume of the rectangle box can be found by multiplying the height by the length by the width. To find the volume, firstly we have to find the different measurements, the height, the length, and the width. Here we are told in the question, and we can see on the diagram, the width is h centimeters, and the centimeters is and its length is twice its width, so it's 2 h. And then we're also told, and we also know that the square of side length x are cut from the corners. These are also the points where the sides of the sheet are folded up. Since we have two squares cut out from the length and the width respectively, we won't have a total length of 2h and h. We will have less than that. Let's take the length, for example 2h on both sides. A length of x is cut off. Since we have two squares, for example 2h on both sides of its ends, a length of x is cut off. Since we have two squares, a total of 2x centimeters is cut off. This means the new length is 2h minus 2x centimeters. We can apply the same thinking into the width of the box. The width before the squares are cut is h centimeters long. Two squares of length x centimeters each are cut out, so we'll take 2x away from h. This gives us new width of h minus 2x. We can label these on the diagrams. We have a length of 2h minus 2x centimeters and a width of h minus 2x. We can label these on the diagram. We have a length of 2h minus x centimeters and the width and h minus x 2 centimeters. From the diagram we are also missing one measurement, the height. However, this requires no calculation. We see that the square are cut all out, and at the bottom of the square a crease is made and the sides are folded up. Since the square has a length of x, the height of the box will also be x. This means that we have our length, width and our height, and we can now find the volume of the box in the formula, which we do down here. So the height by the length by the width. The height is x, the length is 2h minus 2x, and the width is h minus 2x. So we get x by 2h minus 2x times 2x by h minus 2x. We are told in the question that h is 25 centimeters, so we can't let h equal to 25 anywhere in the formula. This gives us x by 50 minus 2x by 25 minus 2x. Now this looks very similar to what we're looking for, except we have x instead of 2x. In order to get 2x, we could factor out 2 from 50 minus 2x. We can factor out 2 to get 2x inside the brackets. We get 25 minus x. Therefore our new volume is 2x by 25 times by 25 minus 2x. Lastly, we can switch around our last two brackets to get 2x by 25 minus 2x by 25 minus x, which is the answer that we're looking for. This first gives us our first 5 marks right here. So we can now move on to part 2 of A. In part 2 we are asked, what is the domain or the possible x values of the V box? So this essentially is asking us for the range of values that x could possibly be. For this we need to consider the values of x that make physical sense for the volume of a box. The volume of the box cannot be a negative value since it doesn't make sense to have a negative volume. Therefore, we have to find all the volumes of x that gives us a positive or a non-negative volume. We can break down each of the factors in the expression. For the volume of the box. Firstly, we have 2x. We know that this has to be greater than 0 to get x by itself. We divide both sides by 2. we divide both sides by 2. 2x over 2 gives us x, and 0. Divide 2 gives us 0, which means that x must be greater than 0. We already knew this, but this is also it's also good to show it mathematically. Next, we have 25 minus 2x is greater than 0. We can add 2x to both sides to a 25 is greater than 2x. To isolate x, we can divide both sides by 2 to get 25 over is greater than x, or equivalently, x is less than 25 over 2 to 25 over 2 is exactly same as 12.5, so we can rewrite this x as x is less than 12.5. Lastly, we've 25 minus x is greater than 0. We can add x to both sides to get 25 is greater than x. If we flip this around, we get x is less than 25. Now we have three constraints for the value of x. We know that the x massification 0, x must be less than 12.5, and x must be less than 25. Since 12.5 is less than 25 and x must be less than 12.5, we can ignore then that x must be less than 25. Combining the fact that x must be greater than 0 and less than 12.5, we can guess 0 is less than x, which is less than 12.5. This is our domain, or the possible x values of the V-box. We get our next 5 marks for this question. So now, next part is, now we're being asked in part 3 of A, we're told to find the derivative of V-box with respect to x. We know the V-box is equal to 2x by 25 minus 2 times 25 minus x. We know V-box is equal to 2 times 2x by 25 minus 2x by 25 minus x. The first thing we can do is multiply out each of the brackets. This will simplify our derivation. We can multiply 2 times 2x. We can multiply 2x by 25 minus 2x. 2x by 25 gives us 50x. 2x by minus 2x gives us minus 4x squared. This all still has to multiply by the 25 minus x, so we have 50 minus x, 4x squared by 25 minus x. We can break the first bracket up into 50x by 25 minus x minus 4x squared by 25 minus x. 50x by 25 is 1250x. 50x by minus x gives us minus 50x squared minus 4x squared. X 25 gives us minus 100x squared minus 4x squared by minus x gives us plus 4x cubed. So altogether we have 1250x minus 50x squared minus 100x squared plus 4x cubed. We usually write each question with the highest order of x first, so we'll write 4x cubed at the beginning. We can simplify minus 50x squared minus 100x squared to give minus 150x squared. Lastly, we have plus 1250x. Therefore, the volume of the box fully simplified is 4x cubed minus 150x squared plus 1250x. We now have to find the derivative of this. The rules of derivatives can be found on page 25 on our log table. Here we can see that when we derivative x to the power of something, for example x to the power of n here, of n, we bring the power down and multiply it, and we minus 1 from the power. We can apply this to our question. Firstly, we have 4x to the power of 3 brings down the power down. We'll have 3 by 4 which gives us 12. The power becomes 3 minus 1, which is 2. So 4x cubed becomes 12x squared. Next we have minus 150x squared. Bringing the 2 down, we'll have 2x minus 50, which gives us minus 300. So yeah, we got this right now, and we just so the derivative of v box is vx equals 12x squared minus 300x plus 1250. So if you have any questions about this, make sure you drop a comment down below, and I'll try and I'll answer your questions. So this question is about a buoy. So starting off with part A, then we're told that a buoy made in the form of a hemisphere cemented by a right cone. We're also told that the radius of the base of the cone is 0.9 meters and its volume is 2/3 of the hemisphere. Then in part 1 we are asked to find the volume of the hemisphere in the terms of pi. So if we turn to page 10 of the log tables, we can see the area of a sphere is equal to 4/3 pi or cubed. This means that the volume of hemisphere is equal to half of that. Then we know that our radius is 0.9 meters, and when we substitute that in, we get 243/500 pi meters cubed. This fraction simplifies to 0.486 pi meters cubed, which is our final answer, worth 5 marks. Now, moving on to part 2, then we're asked to calculate the height of a cone. So we know from page 10 of the log table that the formula that the volume of a cone is equal to a third pi or squared h. But we also know from the question that the volume of the cone is equal to 2/3 of that hemisphere volume. We just worked out. So when we equate those two, the pi's cancel and we can fill in the volume for the radius, which again is 0.9 meters. Then we're left with an equation with only one unknown. So we can solve this like usual for h by dividing both sides by 1/3 times 0.9 squared. Plugging that into your calculator gives us our final answer of 1.2 meters, which was worth another 10 marks. Now, next up we have a part 3, which tells us that when the buoy floats 0.8 meters off the height of its height, it's above water. It then asks us to find the volume of the part of the buoy that is above the water in cubic meters, correct to 1 decimal place. So the only part that is above water in that case is the part of the cone. So the next step I would take is to draw a little diagram of the entire cone and then its smaller triangle. Here is what above water filling in the information we know. Then we know our large radius is 0.9 and the full height is 1.2. While the smaller height is 0.8, then I'm going to label the smaller radius x because that's what I want to find. So if we separate that diagram out into 2 separate triangles, we're left with a similar triangle question. So we can say that x over 0.9 is equal to 0.8 over 1.2. Then we can multiply both sides by 0.9 to get x. That tidies up 3/5. So then we have the radius and we have the height of the small cone. So we can use the same volume formula from the last part to get an answer for volume 0.3 meters cubed. That answer there was worth another 10 marks. 10 marks. Question 8, part 4. Question A, part 4, then wants us to calculate the surface area of the boy in terms of square meters, correct to 2 decimal places. So going back to page 10 of log tables, we can see the surface area of sphere is 4 pi r squared. So the surface area of the hemisphere is half that, so 2 pi r squared. Then we also see from the same page that the surface area of the cone is equal to pi or L. So looking at the hemisphere first, we have all the information we need already to calculate the surface area. So plugging in that 0.9 for our radius, we get the surface area out to be 81 over 50 pi meter squared. Then for the cone, I'm going to draw out a little triangle again, and since it's a right angle triangle, we can use Pythagoras theorem to find L. So Pythagoras theorem gives us L squared equal to 1.2 squared plus 0.9 squared. Cutting that up gives us L squared is equal to 2.25, and then to get L we take the square root of both sides, which leaves us with L is equal to 1.5, and then we have enough information to fill in a formula for the surface area of the cone, and we do that and we get 1.35 pi meters squared. Then we go to get our surface area of the entire boy. All we have to do is add those two surface areas together, and we get 9.33 meters squared. That's the answer. There was worth another 10 marks. So I hope you guys enjoyed this video, and make sure you like and comment and subscribe, and make sure you check our channel for more videos like this. And before we leave, make sure you review key formulas regularly, practice applying them in different contexts. Comment down below for questions as well, and I'll see you guys next time.